Good afternoon, everybody. My name's Glenn Gore, Chief Architect for AWS. Welcome. Bright lights. So, just want to go through what the session objectives are for you in this session. What we're going to say is a little bit of context at the start, because there's a lot of interest around multi-region availability. But when I talk to customers every week around this, it's kind of the key point here is actually knowing when to use it and when not to use it. Because multi-region, while it's really good from increasing the availability of an application, it does come with some significant costs and complexity. We're going to just go through some of those design decisions you make as you go through with this. And just talk a little bit about some of the services and how we make them available as well. Multi-AZ, multi-region, and go through some of the trade-offs. So you want to really understand how you think about availability. When I talk to customers, everybody says their application is absolutely mission critical, and I love hearing that because it means you're going to use a lot of different services. The reality is, though, that you really need to understand availability modeling behind that. And so one of the ways we like to think about this within Amazon is through the well-architected framework. There's 5 pillars, and in this session we're really focusing on the reliability pillar here. Okay, reliability, availability, durability, they're all covered within this. And there's some calculations you should be aware of when you're trying to model availability. There's some key concepts. I used to use these way back decades ago when you were building on-premise equipment. You used to think about mean time between failure, MTBF, mean time to repair. Remember doing those calculations? And so as you do this, particularly in the modern cloud world where you're starting to introduce things like microservices and organizations starting to have hundreds of individual components all working together to create an application that works end-to-end, you're introducing more components. And normally in an availability model, the more components you introduce, the availability actually goes down. For example, let's say we've got 3 dependencies, and they've been modeled on different levels of availability. One's at 99%, the other one's at 95%, and one's at 90%. What's the overall availability of the system going to be? 90% or less. Okay? The chain is only as strong as its weakest link. And so you can do a lot with increasing the availability of an application by putting into a high availability environment, for example. If I have 2 components, exactly the same, one's in one AZ, one's in the other, each one designed to be 90% available, what's the overall availability going to be? 99%. This is the important thing to note. This is why parallelization, distributed architecture is so important when you're running the cloud. Okay, and this understanding the mathematics behind what actually drives availability is critical as you design things. What I see as a common mistake in the industry is we take component 1 and we try to make it 5 nines on its own. Absolutely bulletproof. And while a lot of the focus is put on the underlying infrastructure and the components that we can control, we often forget about the quality of the software that has actually been written. What about the test use cases? What about introducing things like chaos engineering where we're deliberately going to break things to ensure that that availability works under stress? These are things you need to do if you really want to be true about achieving things like 5 nines of availability where you get 5 minutes of downtime a year. You also get instantaneous failovers. This goes back to mean time between failure can be a low number if your mean time to repair is really, really quick. This is an interesting concept as well. So it goes through, and we have some animations here as it fails. So component redundancy increases your availability significantly. So really be aware of what you're doing. Here's the good old chart of the nines of availability. 99%, 3 days, 15 hours. All the way through to 5 nines, 5 minutes. The costs increase dramatically as you go up the number of nines that you're supporting. We talked about the quality and the availability isn't just based on the AWS services. For example, what is the network connectivity between the end users and the application? Is it distributed? Is it going through a single link? Devices, the software quality control. People. I like organizations. You've all heard about Chaos Monkey and Chaos Gorilla that go out whacking instances and availability zones. Some companies use that for people. They literally have a lottery where they just send somebody home for the day. You get a day off from work. That's awesome. But you're not allowed to check your email or contact your phone. And what they do is they see what breaks in the organization when someone disappears. You'll be surprised what has happened. If you don't get a free holiday, and that you should go back and talk to your managers about it. So as you think about these nines of availability, as you start getting into 99.95% and above, this is where you want to start considering a multi-region deployment. And there are different ways that you can do multi-region, which the team is going to go through as they go through this. Considering doesn't mean doing. It just means just have a conscious thought as to whether you're consciously wanting to go down this path or not. The other part of this is that you need to understand how we make our services highly available. We all know how a region works. It's made up of availability zones. There's redundant transit in and out of those availability zones. Each AZ is made up of one or more data centers independently connected. If you use the availability zones, each availability zone is containment of the blast radius. We try to do everything we can to architect and engineer that an availability zone is as resilient as we possibly can make it. Though there are some situations where an availability zone can still be a single point of failure. The control plane, for example, within an AZ. Therefore, what do? You have multiple AZs. You put the component in AZ A, B, C to protect against that. We also have region-wide services that span those AZs, often in a transparent way to you so you don't have to worry about it. For example, using S3, you don't think about what AZ it is in. It's spread across 3 or more. EFS, SQS, Kinesis, DynamoDB, there's a lot of them there where you go through. Some of these are default, you don't have to worry about it. Some of them are configurable. There are different costs involved as you do this. For example, deploying Elasticache. It may be that you just need one cache server in one AZ. It's perfectly okay if it's for test and dev or something that's not critical to the organization. But if it is critical, you can choose how many replicas you need across as many AZs as you require. It's about giving you choice. Even within an availability zone, there are techniques to help protect against single points of failure within the AZ. For example, with EC2 instance recovery. Instance ID, if it fails, just spin up another one, away you go. Another way of increasing, or actually decreasing, that mean time to repair as you go through. High availability, auto-scaling. Auto-scaling groups across the availability zones. These are all tools to allow you to hit pretty high levels of availability within the same region still. We're going to think that you can hit 4 nines, by the way, within a region quite easily if you follow a lot of these techniques. So what are a lot of the reasons you may want to use a region active-active architecture? One of the most common reasons that I see that is defensible, really independent of the availability modeling actually, is if you have geographically distributed customer base. If you've got customers in the US, in Europe, in Asia, you want to have them using their closest region. This helps with latency. But when you're doing this, you've got to think about each service within each region. So for example here, you can see there's users in San Francisco, users in New York, using West and East, and they're using a number of different AWS services there. What happens if one of the services fails within a region? By the way, this is also is how you should think about failure. Often customers talk to me about what happens if the region fails. Well, that's not really actually what happens. What happens is it's normally a component within the region fails. It's a partial failure. And those of you who work a lot in operations know that partial failures are the worst ones to detect and actually work because it's not entirely broken. It's just broken a little bit. Should I keep it running and hope it resolves itself, or do I pull the trigger and fail the entire application over and tell the boss, yeah, I took out the other 70% that was working so I could get it flipped over to the other site, which is 100% working? Doing that in a stressful situation is not always as easy as it sounds. So that service has failed. We're going to therefore fail the region from the application perspective, and we're going to direct all the users to the other region. The other region is still working for the majority of servers. It's just that one service that's having a little bit of a hiccup. This is how you get high levels of availability. What about cost-effective DR? This is another area where you see customers, particularly when doing lift and shift migrations of legacy applications, is I'm going to put the application in one region, I'm going to stage it in another region, but it's kind of cold or warm standby. Well, we all know the problems with that. They fall out of sync. In that moment of need, when you actually need it the most, what happens? It doesn't work. Meanwhile, you're also paying a lot of money for it to sit there idle. So wherever you can get away with using active-active, you want to. You're not wasting money. It's forcing you to be in sync, particularly as you start doing things like more frequent code updates, release cycles. You're just forced to do good behavior. And when you do need to switch from region to region, you know it's going to work because it was already working for a subset of your customer base. So I just wanted to set a little bit of that context up front for you. Around how to think about it. There are use cases for region, active-active deployments. But for the vast majority of cases, I don't see customers architecting all that well within the region using the availability zones and having the code quality and the testing around it and the methodologies to ensure it's going to work when it's most needed there. So with that, I'm going to hand over to Darren, who's going to talk through some of the key technology requirements you want to think about as you start using some of these services. Thank you.
All right. Thanks, Glenn. All right. Glenn's worth a hand. Let's give him a round. All right. So hi, my name is Darren Briskman. I have been doing about, I'm old, 35 years of this stuff, dealing with developing multi-region architectures and deploying them all over the world. So 30 years ago, that meant mainframes and global distributed parallel sysplex. Those of you, I can't see whether any of you are old enough to know what I'm talking about when I talk about that mainframe stuff, but today we have lots of new ways to do it. But having done this for 3 decades, I've learned one important secret about doing active-active multi-region architectures. Ready? Here it is. Don't do it. Don't. It's hard. It adds complexity. Complexity leads to failure. Half the time I've seen people do this, they end up with lower availability because they created a more complex environment that they can't run. People do this for the stupidest reasons. They just think, well, it sounds cooler to be active-active, so let's make our jobs 10 times harder and set it up that way. All right, have I convinced anyone here not to do active-active? All right, fine. Having said that, let's talk about how to do it. But keep this in mind. If you remember only one thing today, it's don't do this unless you really need it. Because multi-region active-active, put it in the same category like chemotherapy or brain surgery. It's a really powerful tool, but don't use it unless you really need it. Right? Don't do chemotherapy if you have a cold. Save it for the really deadly diseases that it needs to treat. So that said, what are the requirements to do this? Well, first one, of course, is a network that you can trust. Right? I need my network to be reliable. I need my network to be secure. I need to have a good backbone. Well, of course, if you're using AWS, we have a fairly good backbone that is connecting together the AZs and connecting the regions back and forth to one another. If you're all in the cloud, that's great. And we've got a lot of great customers, Netflix, Airbnb, not all of them internet companies, places like Kempinski Hotels in Europe or Time Inc. that are all in the cloud. But most of you are not, right? We're in a world, especially if you're with a large enterprise, that you're not entirely in the cloud. So I'm going to have some way to talk back and forth to the cloud. And then, of course, I'm going to have clients that are not sitting in the cloud that need to communicate at some level. So I need to have some sort of VPN or encrypted SSL or some way to communicate over IP and think about ways to make that reliable. So I'll point out, my job is to give you all the questions. The next speaker will talk about the answers. Data replication. That can be synchronous or it can be asynchronous. If I'm doing multi-region data replication, doing it synchronous, I just introduced a huge lag. In AWS, the two regions that are closest to each other in millisecond terms are US East 1 and US East 2, right? That's Virginia and Ohio. That's still a 12 millisecond one-way trip. So if I'm, for example, doing multi-region synchronous on a database write, what would have been a 1 millisecond insert if it was in one region just turned into a 25 millisecond insert because it has to go to one region, write it to the other region, confirm that back to the first region. Now, what if I'm doing, say, Virginia and Singapore? It's a lot more than 12 milliseconds, right? It's usually somewhere around 200 to 300, depending on what's going on. I actually had somebody ask, why don't you just drill a cable straight through the Earth in order to shorten that? Well, engineering is working on that. There's some challenges there. So you can do synchronous, but there's a latency cost, right? And you might think, well, 25 milliseconds isn't that long. Yeah, but that's per insert, right? This adds up very quickly when you start doing these things. Or you can do asynchronous. So part of that complexity, and you'll be seeing this, is whenever we're doing true multi-region stuff, you've got to be able to deal with asynchronicity. You've got to be able to deal with eventual consistency and learn to embrace it and design around it. This is one of the things, the complexity that makes this hard, because very few applications are written with this in mind. So you end up having, you can't just take an existing application set and say, I'm going to deploy this multi-region. Well, you can, but then you're going to fail. So you're going to have to do some significant changes. So asynchronous is useful. There's lots of ways to do asynchronous replication. Girish will walk through a good number of them. But of course, the issue you have with asynchronous is if I'm writing to one part of the world and reading from another part of the world, am I getting current data or stale data? So one thing to think about is, do I care? Does it matter if the data is a second or 2 seconds or 10 seconds out of date? For many applications, that's fine, right? But for some applications, especially things dealing with, say, actual, say, wire transfers or financial transactions, or one that I saw somebody playing with was autonomous driving, and you really don't want to wait for, you don't really want to wait for the car to communicate to the cloud to figure out whether to stop, when it's on the road. So, we're going to have some way to deal with asynchronicity. And then deal with that, is it nearly continuous? Am I shipping it with a delay? Or am I doing a batch? Am I sending things over once in a while? Then, of course, we have synchronizing the code. So 3 basic ways to do this, right? When I stage deployment across regions, because now I have the issue is one region has one version of the code, the other region has another version of the code. So one way to do this is the rolling or canary deployment, right? Canary deployment, I stick a few servers or containers or Lambda functions or whatever on the new code, see if it works. If the canary dies, roll it back. If the canary lives, roll out more. Can your application survive that? Depends on the application. If your application can't survive with some on one and some on the other, then you're probably going to have to do blue-green. So blue-green means I have the existing environment, which is blue, I have the new environment, which is green, and at some point, I switch out all the IP addresses and DNS addresses and whatever. And so now everything was running blue, now it's running green. And what do you do with the blue? You leave it there, for at least for a little while, so that if something goes wrong, you can switch it back. Some people, like Netflix, calls this red-black instead of blue-green. I don't know why. Same concept, though. So if you ever see people talk about red-black deployment, it's the same thing. And then, of course, the idea of parameterized localization. So if I'm running the code, part of that, I'm assuming you put it multi-region for a reason. One of those reasons usually is to do some sort of localization and to try to reduce the end-user latency by having, to say, the users in Asia hit an Asian data center instead of having to go across the Pacific every time they do something. So that gets to traffic segregation and management. So there's a couple of options that we can do this. You can explicitly do this by having different URLs or different approaches, different endpoints. So, east.something or west.something. You could do this with implicit. Route 53 does this really nicely. Have the same URL, but it will get automatically routed. And I can do some tricks in the traffic management infrastructure. So I can throttle things, I can do internal redirect, I can do external redirect. The issue you have, the redirect, is what do you do when somebody gets sent to the wrong region? And then how do you define wrong region, right? Then how one lives with that. Because sometimes the wrong region isn't a problem. I'll give an example of a ride-sharing service that I use frequently, and I live in Portland, Oregon. And they have a couple of places that they have regions that they're running this in. And I always end up logging through Portland. Now, what if I happen to be in Miami that day? Still logs through Portland. Is that a little bit inefficient? Yeah, but I'm using a mobile device. Am I going to notice as an end user on a mobile device a few hundred extra milliseconds? Probably not. So for that, it's the wrong region, but it's okay. So again, things to think about. And then, of course, the whole idea of monitoring. This becomes exponentially more difficult in multi-region environments because I have more things I need to track and more I need to pay attention to. You always need to pay attention to application infrastructure health. I'm hoping that all of you are doing some sort of log analytics on any critical application. I'm regularly amazed by how many people have critical applications that they don't do log analytics. Or one that I ran into, well, yeah, we keep the logs in S3, and then when something breaks, we spin up Elasticsearch to see what broke. Okay, that's putting on the seatbelt after the car crashed, right? You want to be using a log analytics system to see what's going on as it's happening. And then, of course, deal with the monitoring of things like replication lag and code sync and so on. And making sure I'm understanding these globally for how they happen. And the idea of multi-tenancy. So what is multi-tenancy? Well, a tenant is a unit. So sometimes it's a business unit. Sometimes it's a technical definition. But it's the idea that I have multiple independent pieces. So here's an example of doing it based on states. So one of the lessons that we're learning here is white on blue might not have been the best color scheme that we could choose. So if you can't read that, US West has a Texas and a California box. US East has a New York and a Pennsylvania box. And of course, the whole idea here is as I move things around over my backbone, I could move the Texas stuff into US East if I need to for load purposes or other reasons. So the whole idea here is to be able to have that unit as a tenant that I can decide where it goes. And that gets down to the whole idea of static consistency. When I'm doing multi-region, I really want to make sure that each region can handle my entire workload. Maybe not my entire peak workload, but at least my entire average workload. The great thing about being on the cloud is that if you're using AWS, changing that sizing is a matter of somewhere between 0 and a few minutes, depending on whether you're auto-scaling or whether you have to do it manually. And then we have the whole idea of direction of replication, right? So I might have Texas with its core data in one side and then start replicating it in the other direction. And we see that fairly often because one of the things that you generally want to avoid in a database is having true active-active database where people are writing into multiple masters, especially at the same time. Now, as you'll hear today, we've got, and as you may have heard from Andy Jassy this morning, we're developing more services to make that easy. But if you create yourself in a world where lots of people are writing into different regions that could collide with each other, you're going to create complexity and failure. So usually you want any given set of users to only be writing to one side with it replicating to the other side. But it becomes active-active because, as we discussed back over here, I've got some users that are active on one end, some users that are active on the other end. So they're active-active at the system level. That is a much safer and easier way to design this than try to make every database active-active at every transaction. And so if you have to do active-active, please don't try to make your databases active-active-active unless you really need to. And then even if you really need to, try to minimize it. But you've already pointed out you're not going to listen to me, so I'll just give this advice. All right, failover scripts. I'm going to have some way to fail over. I need to reroute traffic for a tenant. I need to change direction of replication. Right? All of these are critical. All right, so what are the architectural considerations in here? One, I need to have tolerance for network partitioning. I need to be able to have a way that if I fail in one region, the application doesn't fail in another region. I want to make sure that API calls never go cross regions, that each region is independent from the other regions. I particularly want to think about the worst possible failure mode, which is a split brain, which is not when a region fails, but when the network connection fails, so each region thinks the other side failed. That works great. How do you fix it afterwards? You've now got two different versions of the truth. They're not easy things to reconcile. So I don't have an easy answer for that. That's one of the things to think about. That's kind of the complexity that I'm fearing when the backbone breaks. Now, in the AWS world, does that ever happen? Well, it's incredibly rare, but that's the whole point of this sort of disaster recovery thinking, is think about those incredibly rare events. One of our great customers is the Church of Jesus Christ of Latter-day Saints. It's the only customer I've ever dealt with that not only plans for catastrophic failure, but cataclysmic failure, which means the end of, literally, they put some of the family history records onto nickel sheets in salt caves to survive the end of civilization. Most of us are working in organizations that catastrophic failure is kind of the worst level that we want to pay attention to. But think about catastrophic failure. So to give my own example, I am a proud citizen of Portland, Oregon. I love living in Portland. I love watching the sunrise over the beautiful Cascade volcanoes. One day, they're probably going to kill me. And in theory, if we have one of those really big events like the Yellowstone and Cascades opening up, it could wipe out not just the US West 2 region, but most of the people living in the northwestern US. That's a catastrophic failure. Is that likely to happen? No. But if you care enough about your applications, you've got to plan for it. See what that'll happen. All right. Minimal data replication. Only replicate what you need to replicate. Right? Does all data need to be replicated? Probably not. Does it need to be replicated synchronously? Probably not. Right? Do I need to replicate my backups? Yes. Do I need to replicate my backups synchronously? Probably not. Does all data need to be replicated continuously, or can there be things that happen in batches? So things to think about. This kind of gets back to a great saying that I've heard from many people, because I've heard Winston Churchill and Eddie Grove quoted this, which is, don't worry about the hard decisions. They're hard decisions because both choices are probably pretty good, so you could flip a coin and you'd be okay. Worry about the easy decisions. Worry about the ones that nobody is questioning. Go back and question, should I be replicating this data? Do I need to replicate this data? Classify the data. So I've got data that is transactions. Right? This is stuff like purchase records. I've got data that is catalog information. This is stuff like product data. I've got events and objects like click streams. I've got server logs and data like that. So that first category is low volume, but pretty critical, right? The other end is high volume, but less critical. Have you ever looked at how many logs your stuff generates in a day? It's a big number. This is the reason you need things like Elasticsearch as part of that solution. I don't know about you. I'm not smart enough to look at 10 terabytes of JSON and figure out where the problem is. So that's why you need to visualize these things. But you do need to do some level of classification and have different rules for the different classes. And then, of course, think about, am I doing synchronous or asynchronous replication? So when I move stuff across from A to B, how is that going to work? So I write my application to a database and have it replicate, and then have it acknowledge, and then acknowledge back. That works pretty well, right? The problem there is, as we said before, we're network dependent, but it does guarantee consistency. Or eventually it times out and the transaction rolls back. Or I can do the write and replicate and ACK, but the danger here, you might have noticed I did the acknowledge before the replicate, is that thing can go out of sync if there's a problem. But that radically reduces that latency on the other end. So basically here you have two bad choices. You have to decide which bad choice is less bad for your application and your environment. Although, as you'll hear today, some of the things that we're doing with DynamoDB and elsewhere help make this less of a problem. And as you may have heard, we are, this morning was announced that we'll be dealing with multi-master Aurora as well. That minimizes these problems. It means AWS takes care of some of it for you. But as you probably know, no matter how good the services are, poorly designed applications can still fail, no matter how good the services are underneath. So we like to think of it as a replication lane. I got a sync lane and a nearly continuous lane, a batch lane, and the one that off the bottom, which is the don't bother lane. Right? Like, do you really need to replicate your logs? Probably not. They're kind of huge. Plus, if you're sticking them in something like S3, they're only going to get lost. They might get lost temporarily if we lose the network connectivity, but the durability of S3 is ludicrously high, right? It's 11 nines. Synchronous is the hardest to manage. The batch is the easiest to manage, but they all have to be managed and watched. So transactions in that lane, catalog in that lane, events in that lane, logs falling off the bottom. So that takes us to our ideal replication system. So the basic minimum here is I have a source, data. Here we say database. It doesn't have to be database, right? It could be a data set, right? But I've got a source chunk of data that's going to go into some sort of replicator into its target. So it should report the replication lag. So I have one way to know how far is that target behind the source. So a good non-database example of this is S3 replication. And you can get the lag in there, but S3 does not guarantee a delivery time. So sometimes it's very fast, but if you have like giant multimedia objects, it could take a long time for the S3. It could take minutes for the S3 to replicate to a remote region. But you need to report that lag. It should record offset, right? How far off is the target from the source? So have an idea of the record offset. Should be able to retry replication if it fails. And it should keep trying until it's successful. Now, many AWS services, as Girish will walk through, will do those steps for you. But you need to make sure that every piece of data that you're doing active-active has these steps in it, that you are having a way to report on it, monitor it, keep trying if it fails, and keep trying again if it fails for the right amount of time. So I'll finish with a few best practices. And these are the best practices a little bit in computer science terms. So if you're not familiar with idempotency means for things that are not changing, you should get the result every time. So for example, for a database that I'm not doing any inserts or updates on, every select statement should give you the same answer. Right? When I run the same select statement, I should get the same answer. Idempotency is the idea that no matter how many times I try the same piece, if it's an idempotent operation, it should remain consistent. This needs to be idempotent across regions if you're going to be active-active. I want to make sure that when I run the same code in one region, it runs the same way in the other region. Eventual consistency. This is the tough part. Learn to embrace eventual consistency. Writing code for eventual consistency is hard. It's probably the biggest piece of complexity. It's the only way to scale. At Amazon, we have spent most of the last 10 years rewriting the monolithic applications we wrote in the 90s when we launched into microservices applications designed around eventual consistency. It's been expensive, it's been difficult, it's been frustrating, and it's let us grow from a $10 billion company to a $180 billion company. Right? These are the kind of things you have to do in order to get to these large scales. Static stability is another way of saying, as I said before, if I lose a region, the other region should operate the same way. So it should be stable from the point of view of the code, which means they all have the same code, they're all running the same way. Exponential backoff is part of the coding. This is how you do try again, right? I'm presuming you're familiar with this pattern, especially if you're a developer, right? You write, it times out, you wait 10 milliseconds, try again, wait 100 milliseconds, try again, wait 1,000 milliseconds, try again. How far does this go? That depends on your environment and what that application can survive. In most of the AWS services, if I have a database primary failure and I'm set up for high availability, my downtime will be somewhere between 30 seconds and 5 minutes, depending on what I'm using. So I need to make sure that can my backoff survive that long? And if not, will it time out in a way that lets the user survive and deal with it? Throttling, how do I deal with the cases that data doesn't always come in at the same rate? This is when we use caching systems and other things in order to be able to throttle and pull in the data. And finally, circuit breaking. This is another thing that you need to write in code that you didn't need before you were active-active, which is when I'm doing things that go across the regions and something's not working, how long do I let it pile up with other things dependent on it waiting before I break that circuit and say this is going to fail? So this is another place where you have to do some monitoring and some automation. So, TLDR, don't do it. But if you have to do it carefully and monitor everything. Now, the good news is we have ways to make this a little bit easier. Girish, come tell us about.
Nice job. Thanks. So Darren laid out all the architecture principles. I'm going to now discuss specifics of various services that help you implement this architecture. And we are also going to see how we keep those trade-offs that Darren discussed in mind when we are using those services and their features. So I got this slide from last year's presentation by James Hamilton, but there was Tuesday Night Live as well this year. And you would have seen that all AWS regions across the globe are connected with each other using a very fat backbone, right? So network has been taken care for you. So when a server in one AWS region tries to talk to server in another AWS region, without you having to tell it, the traffic is going to route over these high quality backbone. So you get the benefit of this even without knowing that you are using it. So this is pretty cool. One less thing to worry about. So backbone is fine, right? It's going to route your traffic. What about the security of your data when it is flowing over the backbone, okay? So people use VPN, right? So you can use VPN. There are a variety of ways to configure VPN. So either you can route your VPN data via your corporate data center, right? That time you can benefit from AWS's hardware-based VPN, which is extremely high throughput. Or you can have a direct end-to-end VPN using software-based VPN techniques, right? So there are AMIs from various partners like FortiGate, which provide you VPN connectivity. There is one downside of this, though, that you get limited by the instance bandwidth, because now you are using instances to run your VPN software. So there is a lot of complexity in doing this, right? It's quite doable. There is a white paper that we have published, as well as CloudFormation template also, which can help you do the setup. But wouldn't it be nice for AWS to take care of even encryption of your data when it is passing over the network? So we heard customers, the thing that we do all the time, and we launched something new. So people love VPC peering because it allows them to connect one VPC to another VPC in a very secure way, and it always works. But it used to work within a given region, but now it works across the regions. So this is a small diagram that shows two VPCs in two different regions being connected. So it takes care of a lot of your headache. It's a free service, okay? So no VPN charges for you. The only thing you pay for is the amount of data transfer at the rate of inter-region data transfer. So that's pretty cool. You have to keep in mind one thing though, since it will form a single network by connecting them by VPN, you should not use overlapping IP addresses. They should be non-overlapping IP address ranges. And yeah, as I mentioned, all the traffic is by default encrypted, so you're all set once you do this. So highly recommended. Go for this whenever you want to connect two regions. Yeah, these are some of the key benefits presented as bullet points. It works just like intra-region VPC. Data always stays on backbone. It's always encrypted. For you, there is no need to use gateways, third-party VPN solutions, saving you a lot of cost, right? And no additional charges, as I said, for VPC peering. All you pay for is data transfer at standard rates. So now let us look into individual services. So S3 is one of the first services that we launched, and people put a lot of their important data in S3 because it is just so reliable, right? 11 nines of durability. S3 now has this feature for quite some time, which is cross-region replication, which very reliably replicates data at one end to the other end. So whatever you are storing in S3, be it your files, documents, or your database backups, all are automatically copied from one end to the other end, and it is done in a very reliable way. And since this is an AWS service, all the security and things like that are taken care by AWS. You don't have to worry about it. It just works. This is pretty cool. Now let us take a look at another place where you store your important data. That's RDS. And as Glenn said in the morning, not morning, just half an hour back, that before you think to do things cross-region, right, or multi-region, first learn to use a given region in the right way, because you can derive a lot of benefits very easily. There are a lot of low-hanging fruits. And one of the low-hanging fruits is deploying a standby server for your master in another AZ, which is independent of first AZ, which has got its own data centers, power supplies, network, and everything. And there is extremely low latency synchronous data copy that is happening from master to standby. So if master is going to fail ever, you always have a standby to rely on, and you can switch over from master to standby within a minute's time. The DNS rerouting happens automatically without you having to do anything. So this is pretty cool. You should always take advantage of this feature whenever you are going to store critical data in RDS. Now, RDS has a neat feature which helps you with multi-region architecture should you decide to go down that route, and it makes sense in many, many use cases. So in such cases, you benefit from a feature called as cross-region read replicas by RDS. You can create a replica in a region of your choice, and that replica is set up and managed by AWS management systems. It works extremely reliably. So currently, the database engines that we support for cross-region read replicas are MySQL, MariaDB, Postgre, and Aurora. If you use SQL Server or Oracle, there are tools specific to those engines which you are free to use. Some of them are available in the marketplace. But these are some of the most common database engines that we have seen people using. So we support out-of-the-box cross-region replication. You just have to turn it on. Yeah, this is a very important thing. Okay, so whenever you are setting up a cross-region read replica, you need to be monitoring replication lag, and AWS provides you that information all the time to you through CloudWatch. So it's very easy to monitor. You can set up alerts and all that thing that you would want to do. What is important here is to note that whenever you are creating a read replica in another region, make sure that it has got enough capacity so that it doesn't fall behind the master. It should be at least as big as the master. That's what we recommend. And if it ever falls behind, there are some steps that you have to take to bring it in sync with the master. But ideally, you should trade away from that zone. You should never have to do that. So now, once we decide to implement a cross-region or active multi-region system, how do we use masters and read replicas of RDS? So here is a very simple scheme. So I have shown 3 regions. Top is Virginia, then Ireland, and then Tokyo. Okay, master is only sitting in Virginia, and read replicas are present in the other 2 regions locally. And servers in all the regions are writing to the masters in Virginia. It looks like a plan that is not going to work because the geographical distance is large. But many a times, all those write operations from remote regions finish in a second or so, which is acceptable in many, many use cases. Yeah, it may not be acceptable in all the use cases, but there are going to be many use cases where it is going to be acceptable. And data is immediately replicated back to the read replicas so that it is available for read operations locally. And in most systems, you perform 100 reads for every write. So this scheme of things, however simple it may look, it does work. But yeah, write traffic goes up, read replica traffic comes down, and you can live happily. But there are going to be some challenges. There is going to be a little higher latency, and there is going to be network dependency. What if the network breaks down? So in such cases, you can choose another design if you can't tolerate those situations. Okay. So what you do is, as Darian discussed, you have different tenants in different regions, right? We have got region A, B, and C, and they have got different tenants being served from there. Each tenant has its own master to which it is writing locally, okay? And each master, for reliability reasons, it is going to have a standby, which is synchronously replicated so that not a single transaction is lost. And it also is going to have read replicas to which it is going to copy data asynchronously so that you have options ready should region A become unusable for whatever reason for you. Okay? The thing that is going to happen though is that since the replicas are async in the other regions, they may lag 1 or 2 seconds behind the primary master, right? So some committed transactions may not have made to the other side when it is time for you to switch over because of whatever reason, but your transactions are always safe in the standby, okay? So you can use data reconciliation techniques which are very commonly known to reconcile the data. If some transactions were left behind, you can always retrieve them later and make the system consistent again. Now, multi-master, Aurora, okay? So we always recommend you having a master and a standby or read replica. We generally advise not going for multi-master designs because it is very difficult for you to manage multi-master replication, both sides simultaneously replicating data to one another. But we believe that there are some good use cases for multi-master design. One of them is extremely high throughput applications. So we today announced Aurora multi-master service. It has write nodes in all AZs, and you can write to any of the nodes. In 2018, we will also be coming out with multi-master Aurora cross regions. So that's going to be pretty cool for you. That's a lot of engineering work. Generally, you will find it difficult to do it yourself, but there are AWS engineers that are going to do it for you. It will be available in 2018. So should you consider to do that architecture, this is a service that will help you a lot. Oh, what happened? Okay, I'm sorry. Yeah. So right now, so far I was talking about the default replication of RDS, but you also can use DMS service. The difference being with DMS, you can replicate selectively. The default replication will replicate everything, but sometimes that is what you don't want. You want only certain tables to be replicated. So DMS gives you that granular control, and DMS is able to continuously replicate data because it works with change data capture technologies, which allow you to just detect the changes and replicate them from one side to the other. So this feature has been is being supported for MySQL, MariaDB, Aurora, and PostgreSQL. So yeah, if you are using those technologies, consider using DMS if you are doing, granular replication. Now, DynamoDB is one of the most common services that people use to meet their NoSQL requirements. And so far, DynamoDB is in 2 regions used to work independently. So if you wanted to keep them in sync, you had to do some engineering work yourself. So DynamoDB is pretty popular because it is highly scalable, it is fast, it is fully managed, and it provides you business critical reliability. So there are many large organizations, including Amazon.com, which deploy DynamoDB for their critical workloads. So you would want to have DynamoDB also replicated. So today we announced one more feature, DynamoDB global tables. So now you can have DynamoDB tables spread across the globe, and you can keep writing to any of the tables, and they will be working in multi-master mode. From one end, data will be replicated instantaneously to the other end, and vice versa, and all the tables across the globe will be in sync for you. So these are some of the benefits, but rather than me talking about it, we have product manager for this service who is going to show you the demo. So over to you.
Thanks.
Clicker.
So if you were at the keynote this morning, you probably heard Andy Jassy talk to you about global tables. Global tables is DynamoDB's fully managed multi-region, multi-master database solution. Just spent quite some time sharing wisdom about why you should be highly wary of active-active database setups. I'm here to show you how easy it is to do active-active replication in DynamoDB. So why would you use global tables? We really think it's about, first, if you have massively scaled applications that have users around the world, you want to deliver, the best possible and fastest performance to all of those users, which means processing the requests in the most local region possible. So essentially data locality. And secondly, it provides a new level of regional fault tolerance, right? Because with global tables, your data is synced across multiple AWS regions, and therefore your application can withstand, a region outage or degradation of service, and your app keeps on just chugging away. Now, DynamoDB Global Tables handles the difficult work of replication for you. It propagates changes from any one region to all the other regions, and it handles any conflicts using last writer wins reconciliation between conflicting updates. So let me go now to my laptop, and I'll give you a brief demonstration of global tables. Great. So we're starting here in the DynamoDB console. Hopefully many of you are familiar with this page. We'll go to our tables, and let's first take a look at a global table that I created before this. So now what you can see here is that this table has some items in it. It's got auto scaling on, and what you'll see that's new is this global table tab. And in this case, you can see that I've created a global table that spans several regions. It spans Ireland, Ohio, as well as Oregon. And that means that any writes to any one of those regions will be propagated within about a second to all of those other regions. So now let's try doing this from scratch. I'll go create a table. I will call it global table example 1. We'll give it a primary key. And rather than fiddle with all of the configuration details on throughput and capacity, we'll just use the default settings for DynamoDB. So this will take a moment to create. What was that? Oh yeah, that happened too this morning. So you can also back up and restore your DynamoDB tables. So we created global table example 1. It looks like it's ready. So now let's go make this a global table. So I go to the global tables tab. It tells me that in order to use global tables, I need to turn on streams. That's because global tables works by using this DynamoDB stream to propagate all item level changes out to other regions. So I'll click Enable Stream. And that'll just take a moment to turn on. And that's ready. Now let's start adding regions. So I'm in Oregon, but I want, let's say, for example, that my application serves customers in the US West Coast, US East Coast, and Europe. So let's go extend the global table to Ireland. Click Continue. DynamoDB will work its magic in the background and create a replica for you in Ireland. It'll apply some global table configuration settings. We'll close out. And then let's do this exercise one more time for Ohio, for the US East Coast. Close out of there. Now let's just, insert a little bit of data. I'll create an item. Let's say this is item 1. And DynamoDB offers a flexible schema, so you can add whatever attributes you want. And let's call this one Hello from Oregon. We'll click Save. And now this item is written. Now, if you just take a moment to do a brief refresh, you'll notice that these two new attributes have appeared. AWS rep update, it says update region, as well as AWS rep update time. Now, these are fields that the global table service writes on your behalf. It tells you where the item was written, and it also tells you, or it tells the system rather, when this update occurred. And these update timestamps are used in order to reconcile between conflicts to the same item. So now, if we go to another region, we go to Ireland, we can see that this table, global table EX1, was created for us. And then we now see that, oh, look at that. Hello from Oregon. And if we do the same thing now, this is in Ireland, and now we go to the Ohio version, we see this replica table appear, and hello from Oregon. And if I can, let's say, write another one. Let's say we'll call this item 2. We'll call this one as well, same message. Hello from Ohio. You'll see that it adds the fields, and then it'll get replicated over to these other regions as soon as you refresh your screen. So this is all well and good if you're doing, kind of like toy writes using the management console. But what if you actually wanted to do, more writes than that? Let's say, for example, that you're doing several hundred writes. So in this case, I've got a couple Python scripts. One of them is going to insert items into the Dublin table, and another one is going to insert items into the Oregon table. Hopefully this works. And here we go. You'll notice that the inserts to the Dublin table are going faster than the ones going to Dublin. That's just because we're going across the ocean here. If you were to do this in real-life production, you probably wouldn't be issuing the request from your laptop. You'd be issuing them from an EC2 instance in Dublin. So now we can start seeing these items are starting to get inserted. And we can go now to, let's go to the Oregon table. And we'll refresh. And you can see now that there's all these transactions coming in, and they're coming from multiple places. Some are being written, in the US to this table, and others are being written from Ireland that are getting replicated over. And if we go, for example, to the Ohio table, which is a passive participant in this, it wasn't doing any of the writes. We refresh here, and we see that all of these writes have been replicated from Dublin and from Oregon into Ohio. So that's global tables for you.
In all regions? Can you announce?
Oh, yes. One last thing, yeah. And to clarify, global tables is available today in 5 regions. It's in US West, US West Oregon, US East Ohio, US East Northern Virginia, EU Ireland, and EU Frankfurt, with more regions coming soon in 2018.
Thank you. Yeah. So guys, I'm aware that I'm the last guy standing between you and pubcrawl. So I'll make it quick. I'll need another 10 minutes to finish all the slides, and there is a lot of meaty stuff ahead. So this DynamoDB replication, it solves a lot of problems for you. But if, as of now, there is a region where a DynamoDB global table is not available, that feature is not available, what you could do is you could use what is known as DynamoDB streams. So streams is basically a place where a log of changes comes. It is something similar to MySQL bin log. So every change gets reported into stream. So you can pick up those changes from the stream in one region. You can have a Lambda function picking it up and writing it to the other region. So why we use Lambda? Because it is just so easy. You just define a Lambda function and you hook it into a stream. You can write it in so many different languages like Java, .NET, Node.js, Python, whatever you like. And all the execution happens as many as records arrive in the stream. And it is all managed by AWS. All you have to do is you define your logic to handle that stream record, whether you want to post it to another region or you want to do something else like write it into Elasticsearch and all that. So Lambda is pretty cool. Lambda needs no more introduction. It's a nice slide that shows how Lambda works. So basically, it picks records one by one from stream. It can also batch the records, and it writes to the other end. And that other end could be anything. So there is one nice thing about Lambda that I want to know that is highlighted in yellow. Okay. Whenever it is reading from the streams, Say, for example, the target is not available. What does it do? Okay. In such cases, the exception is treated as blocking, and AWS Lambda will not read any new records from the stream until the failed batch of records either expires or it has been processed successfully. Okay. This is a very important thing, right? This is one of the features of the ideal replicators. It shouldn't skip some records, right? It should wait until the target system is up, and the moment the target system is up, it should start processing from the place where it got halted, right? So it introduces a lot of reliability in your replication process. Now let us see how to replicate data across other popular products like Elasticsearch and Redshift. All you have to do is your source posts data to Kinesis Firehose in both the regions, and Kinesis Firehose gets this data efficiently into either Elasticsearch or into Redshift. You have to take one care here though, since you want to go same data to both the places, your source needs to have tracking to make sure that the postings have happened successfully. Since you are writing the source, you can always do that. So this is how very easily you can get data replicated across Elasticsearch clusters as well as Redshift, which are some of the most popular products that people use. Now, this is probably one of the most important things that you will need to do when you are deploying a multi-region architecture. You will have to route traffic to appropriate region for a given user. So New York users should consistently land on East Coast. Texas users who are closer to West Coast, they should probably land on West Coast. So how do you do that, right? So Route 53 is Amazon's managed DNS service, which is fully configurable using APIs, which allows you to do this in a very elegant way. So let us take a quick look at the scenario. You have got 3 different regions, and then each region has got some users which are closer to it, and you would want to route each user to that region. But sometimes that region is going to fail, and at that time, when I mean to say region is going to fail, I mean to say from the application's perspective, not AWS region's perspective. Whenever a particular region is going to be unavailable, you would want to redirect users to other region. So how do you manage that in a very efficient and elegant way? So you use a technology of Route 53, which is known as traffic flow. So what is the kind of endpoints it supports? It supports routing to IP addresses, load balancers, S3 website, CloudFront distributions, and Elastic Beanstalk, almost pretty much anything that you want to put behind your systems. So what is that traffic flow does exactly for you? Okay. So traffic flow is a system that implements DNS-based rules for you. Okay. So you can have a simple routing policy, right? You can have a failover routing policy. What it means is go to A all the time, but if A fails, go to B. Okay. Then you could have geolocation-based routing policy, where you say that people from Florida should be routed to one region, and people from Arkansas should be routed to another region. Then it could be geo-proximity-based policy. You don't care which state people belong to, just calculate the geographical distance, and based on that, do the routing. The next one is latency-based routing. Okay? Latency-based routing allows you to pick a region for a given user based on latency. So say, for example, if you're a streaming service, you could always make sure that people land up in a region which is the closest to them latency-wise. And last is multi-value answering policy, which I will not speak much about for now. So I have a question for you. Which of these policies you will use for multi-region architecture? Which is the best policy? Is it geo-proximity? Is it geolocation? Is it latency-based? Or you should have like static rules? What is the best policy? Okay, so one answer you can never be wrong with is it depends, right? So every customer is going to have a different scenario. Sometimes geolocation is going to make sense. Sometimes the content is going to be geo-restricted, right? So you want to make sure that people from a certain part can see the content and certain part can't see the content for whatever requirements. So your scenarios are going to be extremely varied, okay? So people typically want to have a combination of all these rules, a cocktail, right? Can you do that? Okay. So the nice thing is, yeah, the answer is going to be yes, because I'm asking that question and it reflects positively on us. So the answer is yes, of course. and you get this very elegant, beautiful graphical design to design your policies. If this, do that. If this, do that. Okay? And you can't just define very simple policies, but you can also define much more complex policies. Let me jump through the next slide. Okay. So here there is a much more complex policy. So there is a failover rule. Under that failover rule, there is a geolocation rule. Under that rule, there is a again failover rule, and like that. You can have a hierarchy rules, right? First follow this policy. If that policy is not appropriate for whatever reason, then follow this policy, and so on. So Route 53, in my research, is probably the most indispensable tool that you have when you are going to implement multi-region architecture. It's pretty neat. I love it. So now we saw how we segregate the traffic, right? Let us now take a look at some other operational things. How do you do cross-region code deployment? So as Darian spoke in detail, right, you should either do blue-green deployment, right, create another environment, make sure that it is working fine and switch all the traffic over to it. Or then you could base your approach on canary principles, where you have a new version, and rather than switching over all the traffic to that new version of your application, you switch 1% user, then 2%, then 3%, and so on. So these techniques you are going to follow in multi-region world as well, right? But you will have to do it at two places, right? But it is not generally nice to do deployments at two regions at one place, because if you do something wrong, both regions are going to be unavailable all at once, and what is then benefit of having multi-region architecture, right? So never do simultaneous deployments to both the regions. You should always do one region at a time deployments. That is bad, second is good. Okay, so how do you do it in terms of AWS services? So we have published this very nice solution, which is ready to use. You can spin it up as a CloudFormation template, and it is very well explained on that link. This deck is going to be shared. In this system, we see that code is placed in an S3 bucket in region A. There is a code pipeline service from AWS that gets triggered. It does the deployment, testing, and everything, whether you are doing blue-green deployment, canary deployment, whatever. And once it is done, it invokes a Lambda function, which copies the code to second region. Basically, it places it in a certain place from where, using cross-region S3 copy, the code gets copied to the other region. Then the moment it arrives in the other region, S3 sends out notification when new files arrive, if you configure it to. The code pipeline gets triggered in the second region. It does canary deployment, blue-green deployment, whatever you like in the second region. And if all things look good in the second region, it works in the third region. It's pretty cool, very easy to do it. Please do take a look at this blog as well as the CloudFormation template. Now, this is very important, parameter localization. So this is an age-old best practice that people always ignore, that don't hardcode things in your code, right? So you should have a philosophy of storing parameters outside, because your code ideally is going to be the same, even in multi-region world. You want to deploy the same code in one region and the other. Your parameters are going to change based on the location. So you should have some kind of a parameter DB where applications can query their parameters from. And then you should have a neat UI to allow you to configure that parameter DB. So either you can do this all by yourself, or there are some customers who are kind enough to share their solutions. Like, you can take a look at this open source product from Netflix called as RKS, which helps you do that, right? Why reinvent the wheel when a wheel is available? Now, cross-region monitoring. We routed the traffic. We ensured the code deployments are happening properly, but now we want to, keep monitoring it. How do we do that? So first of all, let us ponder how multi-region, monitoring is going to be different from a single region. So first of all, you are going to be required to monitor few more things. One of the most important thing is replication lag. You need to know exactly how much data is yet to be replicated, and you need to know the record offset, basically how many records are yet to be copied, so that you fully know the state of your system, right? You can't live without knowing these things, okay? But last but not least, you want to have a single monitoring system which helps you see what is going on in both the regions. So you can compare and contrast and take decisions. Yeah. So let us take a deeper look into each of these aspects. So replication log, if you are using AWS services like RDS and all, it is directly available in CloudWatch. So your life is easy. If you are using something like S3 file replication, which automatically replicates file from one side to the other, at this time, you will have to develop a very simple custom solution. So S3, whenever a file is added to it, sends out a SNS notification, right? And when the file gets written to the other side also, it sends out a notification. So in this solution, what you are basically going to do is, you are going to observe all those SNS notification. Based on that, you would know things like 10 files were written to region A. I received 10 notifications, but I received only 8 notifications from the other region. So probably 2 files are yet to be copied. That simple math you can implement using this system. It may look like it is having multiple blocks and difficult to implement, but as always, there is a CloudFormation template to do this. Just follow this blog, you will know how to do it. It's very easy to set up and monitor it in a serverless fashion. Okay. So taking it a little further, if you want to monitor your now applications, what are the tools and techniques that you have at your hand? So we see these days that Amazon Elasticsearch has become one of the most popular ways to monitor your logs, right? So so many sources can forward the logs to it, right? You can have a CloudWatch agent running on the server, which can forward the logs via Lambda. Then there are other services that generate logs like VPC, which server is talking to which server, which ports are being used in that communication. So all these logs can also be forwarded to Elasticsearch through this path, okay? Then there are still more services like S3, ELB, CloudFront that provide you logs to monitor. So these are various paths that lead you to Elasticsearch. Then there are still more services that make your life further easier by reporting you various things. Again, you can get all this data into Elasticsearch. And if you're writing some applications and you want to monitor the custom matrices also, like the number of purchases that happen and things like that, you can have a REST API client that can directly post to Elasticsearch. So you can also monitor business transactions there. And this is one of my most favorite, right? You can install a Kinesis agent on the server. You keep on writing logs locally. You don't worry about shipping the logs, right? This Kinesis agent, which is a very reliable component, which works extremely efficiently, will keep a watch on your log files, pick up all those records, and post them to Firehose in a very reliable way. And Firehose, in a very efficient manner, will load them to Elasticsearch. So this is all arsenal that you will need and you have at your disposal to build a very efficient monitoring system. Yeah, and last but not least, Elasticsearch can be deployed across multiple AZs. So it works in a very reliable way because your monitoring system by itself should be highly available. So you have to, again, apply the principles of data classification even to your logs. Okay, the principle that Darian spoke about, all data is not created equal. Similarly, all metrics are not created equal. There are going to be some high-level metrics like user experience metrics, user count metrics, transaction count, how much business happened, what is the replication status of your databases. So these are very critical elements, okay? And then there are some low-level matrices such that HTTP request count, read versus write throughput, cache hit versus cache miss, right? So all metrics are not simple. Some metrics is higher impact or you would want to monitor is much more closely, right? And some metrics is just too much. So what we recommend you is that low-level matrices be monitored using local systems and high-level matrices also be monitored using local system. In the other region also you do the same thing, right? But what you do in addition for high-level metrics is you send them to the other region as well, right? So should region A become unavailable, all those high-level matrices, which are much more important matrices, they're also available to you in region B. Just ship those matrices with region tags and, you'll be fine. So this also reduces the cross-region traffic because high-level matrices are low in volume, whereas low-level matrices, which are like HTTP logs, they're high in volume. You don't want to be shipping everything to everywhere. Okay, this is the last part. There are some open source projects which are contributed by other organizations that I personally feel you should take a look at. One of them, or rather two of them, are Zool and Isthmus. I don't know what is the right way to pronounce it. So what these products basically do is, sometimes what happens is your users, because of whatever region, they end up in a wrong region. So the user who was supposed to go to US West, he lands up in US East, okay? So these projects under such operations, they allow you to route the user's request internally to the other region where it should have gone in the first place. And they also help you in the failover scenarios. So it's beyond the scope of this article to this session to go in more details of those products. I highly recommend you take articles by Netflix on that. One more product which I like from Netflix, it's called as EV Cache. So if you want to keep your cache servers also in both the regions in sync, EV Cache can do it for you. It can make sure that it writes to cache of both the regions so that you have the cache also in the, almost the same state. So being open source, they're available for you to use. Please do take a look at them. So now the conclusion, you can leave in a couple of minutes. Avoid synchronous replication and simultaneous deployments as much as possible, okay? Synchronous replication cannot be avoided in certain rare cases, but simultaneous deployment should be avoided all the time, okay? Design applications for idempotency and eventual consistency. What that means is even if data is written twice, right, it doesn't corrupt your system, or if there is some lag for data to arrive in the other region, the application still is not bothered and it continues to function. Closely monitor your replication rags and code synchronization delays. Have push buttons ready to switch the traffic. So for whatever reason you believe that you can't handle Texas traffic in West Coast and you want to route it to the East Coast, you should have a push button or a script ready to do it because it might involve multiple operations like changing, making some Route 53 API calls, changing the direction of replication data traffic and all that. So you should have push buttons ready should you wish to do such failovers. The next one is make your high-level metrics monitoring systems also multi-region. Otherwise, if a region becomes inaccessible, you completely lose history or track of what happened in that region. Okay, so these are too many details because of which we went 15 minutes over time. So it is definitely an involved exercise even when you go to implement it. So yeah, it requires a lot of careful planning, but we have services like VPC peering, cross-region, DynamoDB global tables, RDS replication, S3 replication, Route 53 for traffic routing. So these things help you achieve the goal of a multi-region deployment, which are unavoidable if you have a global streaming business or global ride-sharing business. There are many new scenarios which requires this architecture to be implemented, and we make your life as easy as possible. Last slide, I promise. Okay, so while it is very complex exercise and it requires a lot of planning and thought, it can be profoundly beneficial if you have users which are spread across the globe and you cannot tolerate much downtime, right? So you should definitely consider that if your business case justifies it. And if you think your business is of this type, consider designing applications for multi-region active-active from day one, okay? But as we say in Amazon, today is day one. Thank you.